Hi, everyone. My name is Joe Kelly. I am the program coordinator at the Rochester Hills Public Library, and welcome to tonight's Zoom program, Climate Change as of 2021, Simple, Serious, Solvable, with broadcast and digital meteorologist Chris Edwards. Please join us for our next program as well. That will be coming up this Sunday. It's an in-person concert. That's, again, this Sunday, November 7th. It is Pam Jaslove's musical tribute to our veterans, and you can sign up for that at calendar.rhpl.org. The program tonight will be recorded. It will be available about 1 week from today on our YouTube channel and also on the Rochester Hills Public Library website. The audience tonight for the Zoom program will remain muted, and we ask that you withhold questions until after the presentation, in which there will be a Q&A, and you can, at that point, once the Q&A starts, ask any and all questions you have in the chat box on Zoom, which when we switch over to the Q&A, I'll put a message in there so everybody is aware of where it is. And again, regardless of that, everyone will remain muted, and we just ask that you hold your questions off till that Q&A starts. And lastly, we'd like to thank the Friends of the Rochester Hills Public Library and their many fundraising efforts. It's thanks to their support and those fundraising efforts that we're able to make awesome programs like this happen. So with all of that said, I would like to welcome our presenter for this evening, Chris Edwards. Chris, please take it away.
Thank you, Joe. I appreciate that introduction very much. And thank everybody for being here this evening. I know that you didn't all have to get into your cars and go out into this coldest night of the season, but I appreciate that you have given up part of your election day and part of your Tuesday evening and perhaps even the pregame of the World Series to spend some time talking about a very important topic that is getting a lot of attention and will just get more and more as time goes on. Of course, I'm talking about climate change, and as Joe said, we're talking about climate change and the title of the program and the theme of the program is Simple, Serious, and Solvable. Those are words you're going to hear again. They're watchwords. They describe the situation pretty well. Before I start to show some slides, I just want to, again, thank everybody for being here. If you have a question that you're afraid you're going to forget, that absolutely can't wait to the end, I am going to leave time for questions. It's my favorite part, actually. I'm going to leave for questions. If you have something that you really want to say before or during the presentation, you can type it into chat. I may look at it during the presentation in a brief moment, but certainly if not that, I will read them when we get toward the end. So I'm going to go ahead and share my screen, and we're going to see some slides here. I'm going to go through a pretty significant amount of information, hoping to finish a little bit before the top of the hour so that we can get to that question and answer part that is fun. And as I said, this is our changing climate, and we are talking about a slideshow which was put together by me in conjunction with the folks at Climate Central. Now, Climate Central is a nonprofit organization that analyzes and reports on climate science, and I've been working with their meteorologists since they started in 2008. By the way, I guess I should back up just a little bit. I am a career meteorologist, a recovering television meteorologist, and I have been either an environmental science reporter or a broadcast meteorologist for many years throughout my career, which began in the 80s. Before that, I was an Air Force weather forecaster. So I'm looking forward to that Veterans Day program that you mentioned, Joe, also. And note too, this is a presentation of facts. These are derived from the latest scientific consensus, and that's what I'm going to be presenting for everybody this evening. So as I mentioned, we're talking about simple and solvable and serious, and that's what this is, our changing climate. Whoops. Let's see, get that back where it should be. Let's see. Not sure what it is. I apologize, we've got a small delay in our advance, but I'll get it in just a moment. There must be some sort of a hang up in my slides. Let's see here. Let me just go ahead and Oh, you check everything out 2 and 3 times before. I'm going to get out, go back in. So, okay, we'll try again to share. Okay, that should work. Cheers. Hmm. Hey, Joe, you can't by any chance see the presentation, can you?
Not currently, no.
Okay, just a moment. No, just 1 second.
Sure. All right, I have a wonderful suggestion here from C. Lou, who does point out, in the meantime, we could talk about, we have that program coming up this Sunday. That is that concert for veterans. And also,
Here this week. So,
coming up, we have some other really lovely programs coming up on Tuesday. Right after that, the 9th, we have a DIA art talk, Art Pride. We've done a couple of art talks with DIA in the past 2 months. So this will be another excellent entry in that program. So please sign up for that if you're also interested. Let's see.
there we go.
There we go.
Now you can see it. All right, sorry about that. Apologize for the glitch, but hopefully we'll just move forward from here. So as I said, simple, serious, and solvable. That's what climate change is. And we're going to talk about the simple, we'll talk about the serious, and we'll give you reason for hope because it is solvable. I will let you know why we talk about all of those things. Now, starting with the simple, the basic idea of climate change is that humans burn fossil fuels. That's coal, oil, natural gas. And this burning puts carbon dioxide, among other things. We'll talk more about that. But remember, we're keeping this simple. Puts carbon dioxide into the atmosphere. And CO2, or carbon dioxide, is a greenhouse gas. It makes the planet warmer. Now, our atmosphere is composed 99% of nitrogen and oxygen. But it's got important trace amounts of other gases, which are the greenhouse gases. They're water vapor, carbon dioxide, methane, and nitrous oxide, as you see there. They're very small amounts, but they have a very large impact. Now, this is a brief illustration of the greenhouse effect, which many of us, if not all of us, have heard of from time to time. This is a brief idea of how it works. Sunlight reaches the Earth from that sunshine about 93 million miles or so away. Some energy is reflected back into space, but some is absorbed and radiated back as heat and back to the ground as heat. Most of the heat is absorbed by greenhouse gases and reflected in all directions, which warms the Earth. Now, it's a good thing this works that way. If we didn't have the greenhouse effect, our planet would be about 0 degrees Fahrenheit on average rather than approximately 59 like it is now, but getting closer to 60, by the way. Now, this idea of greenhouse gas has actually been around for a long, long time. Many of us learned about it fairly recently, but the science linking carbon dioxide to warming has been around a long time. Starting in the 1820s, Joseph Fourier of France suggested that there were gases that were keeping the Earth warmer than it would be without them. In the 1850s, then, Eunice Foote discovered that carbon dioxide warmed the air around it. And just a quick here, high five to women in science, because they have done continue to do, and will do amazing things. And Eunice Foote was simply one of the earlier women in science to do that. Our own daughter is a microbiologist working on cancer research in Seattle. So women in science are doing amazing things. But back to the evidence of carbon dioxide as a greenhouse gas. In the 1890s, Arrhenius from Sweden calculated that a doubling of atmospheric carbon dioxide would raise the Earth's temperature several degrees. And then in the 1930s, Guy Callender from England refined Arrhenius's calculations, and he made the first climate predictions, very crude, obviously. He didn't have computer models. He assembled the first evidence for global warming. And in fact, a lot of scientists, especially used to call the greenhouse effect the Callender effect, named after him. So burning fossil fuels puts carbon dioxide into the atmosphere. There's absolutely no doubt about that. By burning coal, oil, and natural gas, humans are warming the planet. In the 1800s, we started burning more of those fossil fuels, particularly in the second half of the century. First coal, then oil and natural gas. These fuels powered the Industrial Revolution, which raised the living standard of millions of people throughout the world and has led to many great advances, but it also has had this effect on the Earth's atmosphere. Now, if Callender and others are correct, we should see temperature rise as the CO2 increases. CO2 is another name for carbon dioxide. Now, we're going to look at the data. This is approximately the carbon dioxide levels, which have been increasing, especially since the Industrial Revolution, and accelerating in the 20th century. On the right, you see the number of parts per million of carbon dioxide in the air. Currently, we're sitting at about 417 parts per million. That's about 50% higher than pre-industrial levels of CO2. And now you see the relationship with temperature since the 1880s. Obviously, there's some ups and some downs. It's not a straight line. Looks a little like some stock market charts, perhaps, ups and downs, but the trend is very, very clear here. Temperature change since the 80s tracks, in general, the rising CO2. So carbon dioxide is increasing. It's causing the planet to warm. Now, for a moment, I want to take this to a local level and look at Detroit. And this just since the 1970s, so this is probably within the memory banks of a lot of us, the average temperature in Detroit. And you can see that it's been on a steady rise. Has it risen at the same rate all the time? No, it has not. But it has been on a steady rise. And in terms of Fahrenheit, it's about 3 degrees warmer than it was in the 1970s in Detroit. But I want you to remember, we are a very, 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 very small sliver. We'll probably return to this point, but even the entire continental United States, the entire continental US is only about 2% of the globe. So what's happening in our backyard isn't necessarily going to tell us a lot about the world. Now, another point too, when you hear somebody say today was 5 degrees warmer than normal or 2 degrees colder than normal or something along those lines, keep in mind that the normal that they're talking about is a 30-year average. So right now, and we did just switch to this, right now we're looking at the 30 years that's between 1980 and 2010. And that normal is higher than normal used to be. So a day that today is 3 degrees warmer than normal, back in the 60s, it would have been 4 or 5 degrees warmer than normal. So you're sort of chasing a rising bar, if you will, or exceeding more and more a bar that's going up. And when you hear something is warmer than normal or colder than normal, keep in mind that the normal they're referring to is always a 30-year sliding average, and that continues to go up as well. Now, as far as the future, well, we know that carbon dioxide affects temperatures, so we can use that knowledge to look at the future. We use sophisticated computer models to predict how the Earth is going to respond to rising carbon dioxide. Earlier versions of these models from back in the 80s, when they were much more primitive and didn't have as much computing power, predicted our recent warming, though not as fast as what has actually been occurring. But these models tell us two important things. The amount of warming depends on future carbon emissions, because lots of carbon emissions will lead to lots of warming. If we reduce emissions, which you can see in that kind of bluish green emission cuts, then the temperatures will stabilize. They won't rise nearly as quickly. The longer we wait, the worse the issue becomes. So that's the simple part. Let's get into the serious part, which I'll also try to keep as simple as possible. Warming leads to other changes in the atmosphere and in the ocean. This is climate change. We're already seeing warming that's leading to wilder weather and rising seas, which we'll talk about as well. Now, when we look at this bell curve and notice how it slides, we talk about averages. When the averages slide to the right, we also see large increases in extreme heat events and decreases in extreme cold. You'll note that even at the end of this, after it has slid to the right, that doesn't mean there's not extreme cold, or cold certainly. There can be, there is, and there will be, but there's less of it. It generally is not as deep. And on the right side, there's more heat and there's more extreme heat. This is what has been expected. This is what we are observing. And once again, I show you Metro Detroit, and I know that there's a lot. I know that there's a lot on here. I understand that. Let's stop. I see that there's a ton to look at here. Let's see if I can. Noticing here these decades in the particularly in the 60s, 70s, and 80s, because what you're looking at here is the number of records of heat and records of cold. The red bar graphs are record heat, days with record heat, and the blue are days with record cold. You notice back in the late 1800s, early 1900s, there was a lot more hot weather records than cold. Then there was a period in this metro area in the 60s, 70s, and 80s when there was more cold than record heat. Now, this is an interesting trend in Metro Detroit. It may be within the memory of some of us. But again, I remind you, this is one particular point, a relatively small metro area in terms of global scale. When you look at the national records by decade, this kind of trend, this somewhat anomalous or different from the normal trend that we saw in the 60s, 70s, and 80s in Metro Detroit, was not nearly as pronounced around the national, on the national scale, and it was extremely minor when we got to the global scale. Globally, the top 10 warmest years on record have all occurred since 2005. It's worth repeating. The top 10 warmest years on record for the globe have all occurred since 2005. So we need to be conscientious that when we think about our own memory or we think about our own instances, recollections here in Detroit, whether they're of a lot of warmth or a lot of cold or a lot of snow or not a lot of rain or whatever it happens to be, I'm not suggesting that your memories are imprecise, although that does happen, but even if they're right on the money, we are one small part of a massive globe that is enduring a lot of change, and rather rapid change at that. So, that and go to that. There we go. So, milder climates are getting less snow as temperatures are more frequently above freezing. So we're seeing changing snowfall patterns. Globally, we're seeing less snow and shorter snow seasons. And locally, there's potential for bigger snow events in snowy areas, particularly here in the Great Lakes. Late fall and early spring has generally been on the decline, and cold climates where temps are still below freezing can get more snow with more moisture in the atmosphere than in decades past. Now, I've got to tell you, I read just yesterday that because of a very warm summer and a very warm September and the warmest first half of October we've ever had in the Great Lakes region, so we have months and months of warmer than normal conditions, the Great Lakes are on average about 5 degrees Fahrenheit warmer than average. And part of you might say, oh, well, that's cool. We can swim a little longer. And that's true. I know that I personally know people that were swimming in the Great Lakes in October. But good or bad, however you see it, when the Great Lakes are holding more warm water, when we get cold air masses like we're starting to get now in November, lake effect snow is a huge thing in this part of the country. And when the lakes are warmer, you get more intense squalls of lake effect snow. So Is climate change potentially affecting the lake effect snow that we're going to see in Metro Detroit this winter? Yes, very potentially. But because it's snowing hard in an area, maybe harder than you've seen it snow before, does that mean that climate change doesn't have a role in this, or that it's not happening because it's not warming, it's snowing like crazy? No. Snowfall patterns are changing, and in our local area, they're changing in part, although this may seem counterintuitive, they're changing in part because the lakes are warmer than what we're used to them being. Now, in some mountain locations, more winter precipitation is falling as rain instead of snow. And that leads to problems in the west with water, because instead of staying all winter as a snowpack, the water simply runs off. So it's not quite as useful as what it used to be. So that's a couple of things to keep in mind. Now, you've probably all seen these pictures of receding glaciers. I'm not going to spend a lot of time on it. The influence of warming on ice and water is especially apparent in the northern latitudes, actually the poleward latitudes, but in our part of the world, we're going to talk about the northern or Arctic latitudes. Alaska, Greenland, northern Canada, these areas are all warming much faster than we are, or the globe as a whole. So the melting glaciers and ice sheets in Greenland and Antarctica are a growing part of sea level rise in some cases, especially when they are on a landmass. You see what you're looking at here is from the Kenai Fords National Park in south central Alaska. Just in 7 years, the retreat of the Bear Glacier there is pretty dramatic over a 7-year period of time. And these glaciers, huge rivers of ice, are melting quickly. If they're on a landmass, that water goes into the ocean and it raises sea level. We'll talk more about that later. If they're simply floating chunks of ice, no, it does not affect the sea level because it's simply ice being replaced by water. But in many cases, they are on land. And speaking of the oceans, we've been talking about land almost exclusively, but the oceans play a critical role in climate and our changing climate, because the oceans absorb heat and ocean currents redistribute heat around the world. You may have heard of El Nino or La Nina. These are things that affect and impact weather patterns around the world. 30 years ago, we barely understood them. Now we know that the warming oceans are having significant impacts on weather patterns around the country. 93% of the extra heat is going into the oceans, and ocean temperatures, as you might expect, have risen. I do want to point a little thing out to you. I'm not going to use my pointer again because it seems to sort of mess up my, my slideshow, but if you look near the center, and if you can find the United States there, and then look to the northeast or above and to the right, you see all this orange and red all over the globe. But there's a very noticeable, interesting little blob of blue south of Greenland, and that has been showing up consistently for a long time. The water there is cooling, and it took a little time to figure out precisely what was going on, but a lot of measurements have identified this, and scientists have given it a name. It's the Atlantic Meridional Overturning Circulation, or the AMOC. And in a nutshell, what's going on there is the ice in Greenland, that large landmass that shows up black on the screen, the ice sheet on Greenland is melting. That cold melted ice water is going into the North Atlantic, and it's cooling that area consistently. What is this going to do to global weather patterns? We really don't know. There are theories, but we don't know. We have theories that it's going to be potentially calamitous. We have theories that it could be a very minor blip, and a lot of theories that are somewhere in between there. But I point it out because it's sort of a good illustration of the fact that when we look at the entire globe, there's definitely not the same things going on everywhere. There are different things going on in different places, and we can expect the results to be different. And in many cases, we don't know what they're going to be. And that's a good example of that. But we do know that warmer water takes up more space. It leads to sea level rise. It can be as simple as that. Even if you're not adding any volume to the seas, to the oceans, when you warm water, it takes up more space. That's a simple matter of physics and the speed at which molecules move. So melting glaciers and collapsing ice sheets accelerate sea level rise, yes. Sea level rise over the last 100 years is at an unprecedented rate compared to the previous 19 centuries. You see that on the far right there. We've risen about 5 inches, whereas prior to that, we'd go up a little, we'd go down a little. It's very different in terms of what's happened to the ocean levels in the last 100 years. And those higher tides lead to more coastal flooding. Obviously, that's not a big issue for us here in Metro Detroit. But you may have seen or heard of people living in South Florida, particularly where in and around the Miami area, they have what's called blue sky flooding now, where even without a storm or anything at all, when high tide happens, areas flood. And then it may go down in the low tide without any wind or any storm at all. That's because the sea levels continue to come up. And there's a lot of engineering that's already going on near the sea levels around the world, not just in the United States, that's trying to counteract that. We're seeing a maximum number of coastal tide gauges that are simultaneously flooding more so than what we used to see. Now, one of the most important concepts to understand about climate change is that relationship between temperature and the amount of water vapor in the air. Basically, when you have warmer air, there's more evaporation, so the atmosphere can hold more water, and then there can be more precipitation. An increase in temperature allows that additional evaporation into oceans and lakes and soil, so more water is available to storms. Remember, 75% of the Earth's surface is water. So this effectively supercharges the water cycle, increasing the amount of rain and snow in a heavy precipitation event, and also leading to larger droughts in other areas. It leads to more polarizing, if you will, of the climate. Heavier rains in certain areas, no or reduced rain in other areas. The key message is that wet areas or wet seasons tend to get wetter, dry areas tend to get drier, and there's increased potential for extremes in both directions. Look, we all experienced the summer of Metro Detroit that we just got through not too long ago. We had an incredible number of flooding events, and part of that was absolutely no direct relation to the rain. We have infrastructure issues. We have more concrete than we used to have in the past, and that doesn't allow the water to drain the way it's supposed to. We've taken away wetlands. These are all contributing factors. But an additional contributing factor is that the atmosphere is holding more moisture, and rainfall events can be stronger. Reference this around the country. The increase in heavy precipitation events has been seen all over the country, not just in the Great Lakes area. We've seen approximately in roughly a 60-year period, we've seen approximately a 40% increase in the heaviest precipitation events here. It's been even a little more in the Northeast. It's been less in the Western United States. But in all parts of the country, there have been more heavy precipitation events, even in areas like the deserts of the Southwest that are drying overall, but more of the rain that they do get comes in big rain events. And I will tell you, in the deserts of the Southwest, where they might only average 9-10 inches of rain a year, it doesn't do them any good to get 2 inches of rain in a day. That's not the way it should happen. That's not the way it's most beneficial for it to happen, nor is it the way it happened before the climate started to be altered. Did it happen that way sometimes? Yes. Is it happening more often now in the heavy events? Yes, and that's the point that we want to make. Now, as far as, once again, Detroit, rain on the west day of the year, and this doesn't even include the last couple of years, haven't updated this graphic, but the slope and the trend is clear. We are getting heavier rain on the wettest day each year, and that is the trend that goes back about 70 years, and I think it's only intensified in the last couple of years if we plug in what's happened most recently. Now, a brief note about hurricanes, because again, just like rising sea levels, it's not a direct impact on us, although some of us may have loved ones in Florida and other places near the Gulf Coast or East Coast, which are susceptible to hurricanes. And in this particular aspect, there's a little more uncertainty than what some people might suggest to you. Hurricanes and climate change, there's definitely an impact. We have warmer water, so we have more fuel. Warm water is the fuel for hurricanes. A warming ocean, a wetter atmosphere can make hurricanes more destructive because hurricanes are formed by those warm oceans. But it doesn't necessarily mean there are going to be more hurricanes. We don't have any solid evidence yet that that's happening or that it will happen. There's some variation in the models, but it might happen that there are more hurricanes. It might happen that there aren't more hurricanes. What we do show is that the storms are intensifying more rapidly in this changed climate. And also specifically, there's emerging evidence to suggest, very interestingly, just in the last few years, that the forward speed of storms is slowing now, and that rapid intensification is becoming more common. We saw that yet again in the hurricane season of 2021. We saw a number of hurricanes explosively increase in intensity and unfortunately move slowly. A very destructive hurricane that was moving 5 miles per hour and raking your hometown is a lot worse than one that's moving along at 20 miles per hour, because obviously it lingers for 4 times as long and can potentially do 4 times as much damage. So that's a link between hurricanes and climate change. Another part of the country in the western United States that's seeing its own problems, it's kind of the flip side of the supercharged water cycle, it's more evaporation from land. Now this can make dry areas drier, as I said, and we're seeing an increase in extreme droughts. This is a graph going back to the late 1800s of what's called the Palmer Index, which measures drought, overall soil moisture. And the longer the bar, the worse the drought is. And we're seeing more drought and longer periods of drought over the long term than what we'd seen in the past. Again, this is particularly an issue in the western United States. It's not something we need to worry about too much here. But what I'm sure you've seen a lot of is hotter years and hotter fire risk. Basically, the warm, dry conditions make wildfires more likely. And boy, have they gotten a lot of attention over the last couple of years. The wildfires out west that you may be seeing on your evening broadcasts have been worse. Matter of fact, 3 of the last 20 worst fires in California's history occurred this year. 3 of the worst 20 in all of their history occurred this year. And this is in part because of the drier conditions and the drought that I mentioned before, but it also has another contributing factor, and that is, I don't know, maybe you have or haven't been out west in the last 10, 15, 20 years, but millions of trees have been killed out west, specifically spruce and pine tree, of evergreen trees, have been devastated by the spruce and pine beetle. That's a beetle that took over and has killed millions of trees throughout the Mountain West, and those dead trees are obviously better kindling for wildfires and make a wildfire potentially more destructive. Why did the beetles do that? Well, partly, unfortunately, it has to do with climate change. The beetles used to be killed off in the very, very cold days and nights of winter. The beetle larvae would be killed by the very cold temperatures. In the last 20 or 30 years, as the winters out west haven't been as cold, it hasn't killed off the pine beetle as effectively as it used to. It was therefore able to multiply more than it used to, and that makes these susceptible areas even more susceptible. Vegetation drying out, creating that fuel to burn so that the fires spread faster and they spread farther. So there's a different part of Sirius, though, as well, in addition to what I've just touched on. It's affecting nature in a more broad sense. It's affecting our health, and it's having impacts on our economy. Now, some of the impacts from extreme weather are some of the ways that most people experience climate change, like we've already discussed: more extreme and long-lasting heat, heavier downpours, which we've certainly seen in southeast Michigan, more intense droughts, higher risk for wildfires, and stronger, more rapidly intensifying hurricanes. By the way, I forgot to mention this at the top, but in terms of droughts, I've been studying climate change since the 1980s, but I really intensified my studies of climate change as a meteorologist in the summer of 1988, which some of you may remember was an incredibly hot and amazingly dry drought summer here in southeast Michigan and throughout a lot of the Great Lakes. We haven't had a drought of that nature and that severity since then, which is a long time. That's great. But drought can happen here, and it probably will happen here again in the future, as hard as it is to imagine that, as much rain as we've had lately. But one of the other impacts of climate change that's good to remember is that it has already been very, very costly. Will making change cost money? Yes, it will. But billion-dollar weather disasters have become more and more common. Extreme weather events are becoming more costly. We've seen these rises in weather and climate-related disasters. And one of the common ways that these are measured are a weather disaster that resulted in damage at or above $1 billion, billion with a B. So how many billion-dollar weather events have we had? You see on the left, that's a map showing the states. The darker the red color, the more such disasters they've had. We're fortunate in Michigan, we're in a little lighter color. We have fewer of those. You might notice that the states that border the ocean have more of them. That's largely because of hurricanes, because in many cases, it's hurricanes that are these billion-dollar disasters. But on the right-hand side there, you see in 2019, the billion-dollar weather events, they got up around 15 or so, which is much higher than they had been before. But not on this graphic. There were a record-smashing 22 such events last year in 2020, like we didn't have enough going on in 2020 to distract us and make things challenging for us. But last year there were 22 different events that were $1 billion or more, and there have already been 18 so far in 2021. Both those numbers smash previous records. And by the way, for those of you who are wondering, who are thinking back to Economics 101, these are all inflation-adjusted numbers. So this isn't because the dollar buys us less. These are inflation-adjusted numbers. These are events that are having more costly impacts than what they had in the past. So animals and ecosystems are also being affected, and they're trying to adapt. A lot of times I hear people say, well, there has been change in the climate and we will adapt, and animals and ecosystems adapt. Absolutely true that there have been massive changes in the climate over time. What's different about this is the rapid nature of this. And it is happening so rapidly that animals and ecosystems aren't able to make the adjustments that they often can. Many are moving north or poleward to higher elevations or farther poleward if they can, but the seasonal cycles are often being disrupted, with blooming happening earlier in the spring, and then there can be mismatches between predators and prey, between something that uses something and when and where that's going to be available. Some ecosystems like coral reefs are particularly sensitive to temperature increases. They've been severely impacted by warming and the heat waves and the rising temperatures in the oceans themselves. As far as our health, it's not doing us any big favors. I mean, it is sort of nice. There's no doubt about it. It's sort of nice to be able to get out and take a run or a walk later in the fall or earlier in the spring than what you're used to. And there's no doubt that those can be some positive impacts. But the negative impacts are something you may or may not think about. For instance, warmer conditions make air pollution worse. It amplifies wildfires. So clearly, as we talked about already, that leads to significant degradation of air quality. And burning coal and diesel are also, along with wildfires, CO2 sources. Now, the heat impacts us directly, increasing the number of days where our activity outside is dangerous. And that's especially important for outdoor workers, perhaps athletes, those with asthma or similar lung conditions. Mosquito and tick-borne diseases become more common for a longer period of time, spreading into new locations and tending to stick around longer. Allergy season, asthma and hay fever seasons are extended, and these high carbon dioxide levels actually can even make something like poison ivy more widespread and a bit more irritating. Now, food and farming is also impacted. The climate change impacting how we produce food and the people working on those farms. These wild weather events, flooding and drought, obviously, clearly can impact crops and farmland, and the planting zones are continuing to shift northward, not only all over our country, but all over the world. Just read an article about a week ago about how those famous farmlands in Colombia for growing coffee, which many of us are addicted to, they are on a course to, within about 20 years, not be able to support coffee anymore. And that's obviously having a lot of impact on those people, and ultimately it could be on what we do with our morning beverage around the world. So this next graphic shows us a little bit about the difference. You may have heard a little bit about trying for 1.5 degrees Celsius. As a matter of fact, it's in the news a lot this week, what's called the COP26 or the COP26. It's a big conference in Glasgow, Scotland, with parties from countries all over the world are coming together, and they're trying to come up with solutions for the climate change disaster or the climate change unfolding disaster that we have. They're working on that, and you may, in that context, hear about 1.5 degrees. We're trying to keep things at 1.5 degrees. Now, that's 1.5 degrees Celsius, the total amount of warming to try to keep it to that number or less. And on the left-hand side, you see the sorts of impacts, for instance, the loss of 70–90% of coral reefs. The figure below it, I think, is more impactful for many people. 350 million people in urban areas will be exposed to severe drought. That's if we keep it to 1.5 degrees. If it goes just 0.5 degree Celsius more, which is about 1 degree Fahrenheit approximately, the differences are huge. So every 1/10 of a degree matters. In 2015, the world came together, signed the Paris Climate Agreement, aiming to limit warming globally to 2 degrees, that one on the right, with a hope to keep it at 1.5 degrees. So I'm showing you this just so you can kind of see the difference. A 1/2 degree Celsius, if we're even familiar with the Celsius scale, may not seem like much, but it has very significant impacts on people and ecosystems and the planet as a whole. And that's part of what the gathering in Scotland is trying to advance. It's sort of the next stage from the Paris Climate Agreement, which was agreed to in 2015. We're trying to avoid catastrophic sea level rise, allow some coral reefs to continue to exist on the planet, and reducing the number of people exposed to flooding, storms, and fires, and save money that we would need to spend on disaster recovery. Instead, use it on protecting and moving sites because of things like sea level rise. Which brings me to Solvable. Yes, it is solvable. And let's talk about that, because increasingly I'm hearing people, particularly young people, who seem to express that it's too late. And I just want to say emphatically right now, as we start talking about solutions, it is not too late. It is late. It is not too late. And we need to make big cuts, and we need to make them fast. And especially in order to stay below 1.5 degrees Celsius, we will have to act rather quickly and drastically. We have to suggest, a lot of studies suggest we have to keep those CO2 levels to where they are stabilized before 2050, which may seem like a long time, 29 years away. It really isn't in terms of the kind of changes that have to be made across the world. But if we do that, make those emission cuts, it's going to have a significant difference on the climate and how we move forward in the future world. Now, a little breakdown here back to the US. Where do our greenhouse gas emissions come from? And it's an oversimplification, but about 1/3 of them are transportation, about 1/3 are electricity, and a little less than 1/3 are industry. We get a not inconsequential amount from commercial and residential, and then an amount from agriculture, as well. We have solutions to reduce emissions from each of these sectors. Let's start with energy, renewable energy. You probably heard something about that. Where the solar energy is greatest is in the western and southern United States. As you can see there, those darker colors, we can generate a lot of electricity that way. It's a climatologically sunny area, especially in the southwestern US. There's high potential for solar there. The front range of the Rockies, in kind of that dark blue on the right, that's where the wind tends to blow more strongly, all the way down into Texas. And those are great possibilities for generating wind energy. The renewable energy is growing, and that further growth, of course, will displace some people and will create a lot of new jobs as well. So how do we electrify transport? We can produce electricity from renewable sources, and we can use that energy to move us around. It isn't just Elon Musk that is thinking this. Obviously, the Detroit automakers understand this and have made commitments just in the last several months to make massive changes to the cars that they produce in a short period of time, relatively speaking. So we're converting cars, buses, and trains from fossil fuels to run on clean electricity. Electric vehicles are getting better and cheaper every year. Battery capacity is growing. These are parts of the solutions. EVs are much simpler to maintain, and we're increasingly putting in more places where they can be recharged. And as I alluded to before, GM recently committed to an all EV fleet by 2035 and carbon neutral as a company by 2040. You may hear that term a lot. Basically what carbon neutral means is that you are capturing or reducing as much carbon as you are emitting as a company in this particular case. It can be as a person, as a country, as a household. Brief note or two about better buildings as well. We can pursue dynamic glass and insulation. We use energy to heat and cool our buildings. Architecture and building can increase the energy efficiency. There are simple things like improving that insulation that can be done. Electric heat pumps are efficient replacements for natural gas or heating systems. They're also cool in the summer, so there are ways that we can make some progress in that area. And even in agriculture, we can reduce emissions through the farming practices that are used while also creating better crops. Better agricultural practices can lower methane emissions. Part of today's news was that our president announced that There's a significant effort to reduce methane that the United States produces, which is wonderful. However, methane doesn't last as long in the atmosphere as carbon dioxide. Methane generally is gone from the atmosphere within 10 years of when it's released. Carbon dioxide takes over 1,000 years to be released. So it's good. It's good because methane is a very potent greenhouse gas, but we need to put a lot of our focus on that carbon dioxide as well. Reducing the tilling or planting on cover crops can keep carbon, water, and important nutrients in the soils, and composting food waste reduces the methane that is emitted, and that can help as well, whether it's on the farm or even in people's backyards. It recycles fertilizer back into crops. And it's important too that I alluded earlier when I was talking about the flooding rains in Metro Detroit, how we've reduced wetlands here as building has continued. That's an issue all over the country, indeed all over the world, in some places much worse than in our area. But plants take carbon dioxide out of the atmosphere and they convert it into plant tissue. And productive ecosystems like grasslands, wetlands, peatlands, forests can accumulate carbon in the soils and keep it there. And maintaining and protecting these areas from development helps prevent carbon from entering the atmosphere, and also helps to absorb potential floodwaters, whether it's from hurricanes or heavy rains. Those coastal wetlands also help to buffer against flooding. And in the Metro Detroit area, some numbers for you that may or may not have a meaning to you, because it's hard to imagine what 1 million tons of carbon dioxide really is. But it's a pretty big amount, and that's what's taken out of our atmosphere in Metro Detroit per year by the trees that are here. I'm going to get a little bit later to things that an individual can do, but planting trees is one of them. The trees that we have in Metro Detroit avoid over 5,000 million, or if my math serves me correctly, about 5 billion gallons of storm runoff, and also absorb about 55 million pounds of air pollution. Trees can do magic. Trees can do wonders. And as the old saying goes, the best time to plant a tree is 20 years ago. The next best time is tomorrow, even though it's going to be cold tomorrow. Now, when we talk about this being solvable, and I addressed earlier that some people feel like it's too late, that we've already done too much damage. That's not true, but this is a big job. But let's think just for a moment. We've done big things before to meet this goal and stay close to this 1.5 degree warming target. We need to make these big changes. We need to make them quickly. Now, we've done big things in the past. Indoor plumbing. I mean, indoor plumbing and electricity vastly changed the quality of life for people in cities and all over the country, and indeed all over the world. It continues to do that in many cases to those that have not had it or don't yet have it. Now, the space age then was another huge change. What a challenge that was. It ushered in new technologies and huge computing advances, provided satellite data that continues to help us learn more about the environment and has impact after impact that's positive. And how about the internet, the information technology age, a revolution of its own kind? Mobile phones, they've transferred our world just in a couple of decades. The first iPhone is not even 15 years old. Imagine that. This is rapid change on a huge scale that we have done. And reducing emissions is win-win. It's not zero-sum. These changes create jobs, they create new industries, they keep us safer, and they limit future expenses from disasters that we talked about before. Ultimately, many of these issues, the big in scope though they may be, kind of go back to being personal. And I'm getting personal for just a moment to show you why I work to combat climate change. Particularly the two young people on the right there in the blue and salmon shirt happen to be our daughter and son, because I'm thinking about not only them, but I'm thinking about their children, and I'm thinking about those children's children, because it's going to make a huge difference in the world that they live in, what we're doing over the next 10 to 20 years, starting with today, literally today. And that's why I work to combat climate change. So as I get ready to wrap here, I want you to at least come away with an understanding that climate change that you hear so many different things coming from so many different places and varying opinions, and it can get polarized and it can get strident. It really is simple because it's well understood science that goes back to the 1800s. It's serious because the impacts are already being felt. This is not something that's coming. It's something that is here. It's already being felt. It was 108 degrees in Seattle this summer. It was 116 in Portland. We never even thought those cities could get to those temperatures. And if we did, we thought it'd probably be at least 20 years before it happened. Blew apart previous records, and that's just in the last few months. It's here, it's serious, but it's solvable. We have the knowledge, we have the technology to make the changes. Do we have everything we need to make the changes? No, because some of it is will, and that's complicated. And human nature is complicated, and change is tough. But we do have the ability to make change. We know what we need to do, the solutions exist, and it will make life better. So I just want to give a quick special thanks to Scott Deming, who is a scientist and prof at the Colorado State University, Professor Denning, for helping to put together the simple, serious, and solvable framework that I used. I alluded to this before, and I include this because time after time, I would wrap and I would finish and people would say, well, what's something that I can do? So I'm addressing this question even before it's asked. So here are 10 things in no particular order except the first one. The first one is probably the single most important thing that you can do of all the things if you are concerned about climate change, and that is talk to people. Do what I'm doing right now with anybody and everybody that might listen. It doesn't have to be a 45-minute slideshow presentation. I was with my nieces just a few days ago, and we were sitting around a fire, and we started talking about coral, and they said, well, there's not going to be any coral reefs left, and we started talking about climate change. It can be as simple as that. You have more information now than you did hopefully an hour ago to begin those talks, to participate in those talks, to find out more so that you can feel better about what you're talking about. So that's number one, talk to people about climate change. Some other ones, some of which are very self-explanatory. Plant trees. I talked about how important they are for the entire carbon dioxide budget. You can fly less, and very closely related, purchase carbon allowances, which is sort of like offsets, but it's a little different. If you need to fly, and understand people need to fly sometimes to get places, I get it, I do it too. Carbonlighthouse.org is an organization to which you can donate, and they will purchase carbon allowances essentially for emitting carbon. They purchase them, they take them off the shelf, they'll never be used. That's essentially what that boils down to. But if you're interested in more, you can look at that website. Eat less meat and dairy, and if you can, try for locally produced food. Those things help if you can do that. Whenever you can, however you can, if possible, leave the car at home. Does that mean don't use the car anymore? Of course not, not at all. But it means leave it at home if you can, when you can. Little bonus, saves you money also. Reduce your energy use. I talked about insulation. It isn't just for businesses. Insulation, fixing leaks, things like that. Another thing that can save you money. Number 7, investing responsibly. More and more people are doing that. They're taking a look at how they're investing their retirement funds, and they're seeing if they're invested in things that they think might be positive for the environment, and maybe other ones that aren't positive for the environment, and they can make decisions accordingly. Number 8 is, in general, cut your consumption and waste if you can, in any way that you can. Again, you can save money by doing that. If you don't update your wardrobe every 2 or 3 years completely, as a hyperbolic example perhaps, then that definitely reduces consumption and waste. You can join a local group. There are so many of them. I don't even know where to start. I'll let you decide. I suggest that you type into Google Michigan Groups Tackle Climate Change, and you'll probably see something that might be a good fit for you in your local area. And finally, and appropriately on this election night, you can vote with climate issue in mind when you do that. And if you have further questions for me, want to reach out to me, you can see my email address there. It's rfrhomes@live.com, or my Twitter handle, Chris Edwards it's at Chris Edwards TV. Before I open it up for questions, though, I want to also bring your attention to what I think are 2 great books. I've read a lot of books about this issue over many, many years, These are two recent releases that I strongly recommend. The first one by Professor Michael Mann is called The New Climate War. It's a little bit more focused, as this blurb in front of you shows. It's a little bit more focused on the history of the climate change campaign, and it is somewhat more political in its scope, but it also offers some forward-looking solutions, as it says, a battle plan for how we can save the planet. And a different one just released within the last few weeks, a very different sort of a focus. This one is called, this one is by Catherine Hayhoe, called Saving Us, and it's really focused on communication. It's focused on how we can communicate with each other about climate change and do so in a calm way, so we can find common ground, so that we can have a kind of a discussion that's what's needed for us to move forward, to see more things that we have in common than things that separate us. And so I leave you with those things, and I will jump right into chat here. All right, looks like we have a number of chat comments. Okay, I'm looking for questions. Early in the presentation, there was a slide on Detroit's warming. There's a significant increase. There was a significant increase from the 80s to the 90s. Please comment. Well, again, these increases in one particular area, they can be subject to just very minor perturbations. That might have been just a few warm years that we had. I can't attribute it to any particular thing, other than the fact that perhaps in the 80s we were slightly depressed in terms of our number of warm days for a variety of reasons. In the 90s, perhaps less so. But I guess the short answer to your question is it's really impossible to do that when you're looking at 10 years of data and one particular point in time, even though I was on the air during that whole time talking about our weather. There's no particular specific reason to attribute that to. It's just part of the overall trend. And you see that in a lot of cities, by the way. All right, so Joe mentions that anybody can have questions in the chat. Methane reductions were less important than CO2 reductions. Okay, I'm going to read this. You mentioned how methane reductions were less important than carbon dioxide reductions. Are there any other common misconceptions people interested in fighting change might have that should be cleared up so that they can focus their activism in a more effective direction? Well, that's a great question. I would say, you know, the one about methane and carbon dioxide is important. I would say that there is a misconception that an individual's efforts, positive or negative, really don't have that much impact. And I understand why a person would think that, but that, I believe, is also a misconception. That your actions, and I listed 10 possible things that a person could do, your actions can make a significant difference. Obviously, your actions might spur other actions, which spur someone else's actions. And we get into one of those positive feedback loops where more and more people start doing things. They can be little things. They can be little things like using, instead of using plastic water bottles, using a reusable container. And then somebody else sees that and they're like, oh yeah, okay, I guess I could do that too. You might not even know the impact you have. So I guess the main other misconception that comes to my mind is believing that your actions or your family's actions are not impactful. That is not the case. That we have a lot of evidence to prove otherwise. Is there any other way to get China on board our carbon dioxide emissions and how to prevent slash and burn in the Amazon? Both great questions. Unfortunately, regarding China, President Xi did not come to Stockholm. That's very disappointing. There's no doubt that what China does is going to have a large impact on global emissions over the coming years. There's no doubt about that. And they have been back and forth on commitments to doing things. It would obviously be much better if he, the president of China, was at the table. And it doesn't appear that he's going to. So is there any way to get them on board? International pressure. Is that going to work in an essentially communist regime? Questionable. But I think the more the world unites and comes to the same page, and the more the world makes adjustments, China may feel some pressure in that regard too. I will say this, from the things that I've read, they're farther along than they were a few years ago. Do they still have a lot of work to do? Absolutely, yes. But I personally am not of the opinion that people that say, well, China isn't going to do what they need to do, so why should we do anything? I just don't believe philosophically that that's the right path forward. But there are some people that might, and there are perhaps some countries that might. We are what's called a legacy contributor. We've contributed greenhouse gases for a long, long, long time. Whereas some of these countries, not just China, but some of these countries are still ramping up in that regard. And so there's obviously a difficult balance in terms of, hey, we're just trying to do what you did. These are difficult conversations to have, whether on a personal level or between governments. And then the second question is slash and burn in Amazon. I believe, however you feel about him, I believe that just today, Jeff Bezos announced that he was going to commit, I believe the number was $3 billion to buy up lands or to somehow reduce the burning of the Amazon rainforest that's being done. Again, many people are doing that. Many people that live far below our standard of living are doing that just to survive. The slash and burn is still going on there. So it's a difficult problem. Many of the countries recognize that they need to do something, but they have a lot of challenges in terms of doing it. But is there anything that can be done? Once again, I would direct you to Google. There are organizations that are working on that, and basically they're trying to come up with other solutions for these people in these areas to keep themselves alive other than burning rainforest. And perhaps you can do some research and find an organization that you think is making the right moves in that direction. And if you were able to, support them financially would be a possible way to do something like that. Michigan's invasive species, Phragmites, it's everywhere. I will always answer what I know and tell you that I don't know. Phragmites, it is an invasive species. I have no idea if it's related at all to climate change. We do have more instances of invasive species here than we used to, and some of that is probably related to climate change and some of it probably isn't. It's a good question. Unfortunately, Janet, I do not know the answer whether or not that particular invasive species is related to the changing climate. Looks like we got that a couple of times. Would improve public transportation so that less people are driving their cars be helpful? In a short answer to that, yes. The more public transportation there is, the better it is in terms of the amount of greenhouse gases that are released. More and more transit systems around the country in metropolitan areas, and ours in Detroit, of course, is not as developed as many metropolitan areas, but more and more of them are running their buses on natural gas, which is a greenhouse gas, but it is less damaging to the environment than traditional gasoline-powered internal combustion engines. It's sort of a bridge, and a lot of times when we're talking about how we move to a different era, we're doing bridges. So natural gas burning vehicles are better, but they're not as good as a complete clean energy vehicle would be, but it is improvement. But either way, the buses and well-developed public transportation do go a ways to addressing this issue. So it looks like I'm caught up on the questions that are in chat. Joe, do you want to open anything else up while I keep an eye on chat and take a short drink of water?
Oh, excuse me, just one.
Also see if okay, thank you, Michelle. Were any lessons learned by the shutdown of COVID when people weren't driving and flying? Wow, that's an interesting question. Were lessons learned? Well, we certainly saw that there was a dramatic reduction in the amount of carbon dioxide released into the atmosphere. We measure these things around the globe every day. And the reduction in those gases during 2020, particularly during the heart of the lockdown, between about March and July of last year, it was dramatic for obvious reasons. People weren't going places. People weren't flying, people weren't driving. There was just a whole lot less traffic moving around. Were there lessons learned from that? Perhaps global coordination can make a difference that you can see in a very short period of time. Maybe that's a lesson. Unfortunately, even though COVID is not completely behind us by any means, unfortunately, the greenhouse gas emissions are almost back up to where they were in 2019. Not quite, but the emissions are very close to that. So were they enduring lessons? I don't really know. I'd like, being essentially an optimist, I'd like to think that the kind of global coordination which we attempted to address the global pandemic might bring us some individual lessons on how countries can work together and coordinate. But a cynic could say that the different countries' reactions to the pandemic and the unbalanced effect that it had because of a lot of economic issues just proves that it's going to be extremely difficult for us to get the global coordination that we need to really tackle climate change. So again, I like to be an optimist. I'd like to take the positive lessons that we got from it. But beyond that, I think time will tell.
Sorry for stepping away there for a moment. My cat decided to jump on top of a door, so I had to retrieve him. So,
well, that's one of the great things about Zoom, isn't it? The cat can have quite an impact. There's a question that just came in. If contacted, will you do this presentation for other libraries, museums, senior centers, etc.? That's part of the reason I put my email up. Reach out to me, please, because I have committed myself. By the way, any honorariums I get for this are donated to climate change, specifically to buy up carbon allotments. And I have committed myself to doing this as part of my efforts post-television. And so the short answer is I will definitely consider it, depending on the schedule and things like that. So yes, please don't hesitate to reach out to me on that email address that I left or through my Twitter. rfrhomes@live.com again is my email address. And I will consider doing that because I'm trying to do the #1 thing on the top 10 list of things that I suggested people do, and that is talk about it. And that's what I'm doing tonight. And I'm extremely grateful for the attention that you all have given me. I'm fine to continue to answer questions. Believe me, I'm absolutely fine. But I know that some of you are perhaps leaving. And to each of you, I want to say thank you for your kind, respectful attention. I know it's not an easy topic, and it's not something that can be completely covered in a 1-hour presentation. I understand that. But I hope it's been helpful to move you along in your journey of understanding and knowledge about this issue. And I hope that you've left with a clear idea that it is not too late, that this is solvable, and that it starts with each and every one of us. And I keep thinking about my kids and unborn grandkids, and I'm sure you can think of a lot of personal reasons on your own why you might want to consider taking some sort of action, at very least to try to find out more. So thank you for your time this evening and helping us move that forward. Any other questions? All right. I'm going to need a moment to check my notes, and I appreciate the question. Let's see here. The question, by the way, is, can you please explain the part where you said eating less meat, dairy reduces emissions? How does climate change negatively affect oceans, i.e. seafood having higher levels of mercury? Okay, there's a couple of different things to unpack there, and I will first address the eating less meat and dairy. In a nutshell, raising meat, livestock, things of that nature, it uses an extremely large amount of water and other resources, but primarily water. And water is something that we want to do the best we can to conserve for a variety of reasons related to climate change. So that is what that's about. Same thing with dairy. Basically, the production of dairy products is very heavily resource dependent, more so than eating things that are grown. It doesn't mean everybody needs to become a vegetarian, One of the things that's suggested to kind of get a start is try to take out eating meat one night a week, as opposed to what you might do. It reduces the environmental impact, especially red meat. It has the impact of using more resources. If you choose fresh seasonal produce grown locally, helps reduce carbon emissions from transportation, from preservation, and from prolonged refrigeration. So that's why the locally helps too. You're using fewer resources that can produce greenhouse gases. Now, how does climate change negatively affect oceans? In a nutshell, it raises the temperature of the oceans. It changes the ocean currents, which can displace seafood. It can make it difficult for species of fish to live where they previously did. And that's all outside of the higher levels of mercury, which are a different kind of pollution problem. You said, i.e. saving seafood having higher levels of mercury. It's kind of unrelated to that, but the warming oceans, especially quickly warming oceans, because remember, about 93% of the heat is actually going into and being absorbed by the oceans. That impacts things. For instance, they're seeing fewer and fewer, the price of crab in this country has skyrocketed, and it isn't all just because of COVID and supply chain and a lack of truckers. There are fewer of the crabs to catch in the Northeast because those North Atlantic waters are warming quite quickly, and they think that's part of a long-term trend. Did India come to the summit? They are number 3 at burning coal. I believe that they did, yes. I'm not sure, but I believe that they did. Let's see. Forgive me, I'm reading these cold. What was one of your most memorable events while on the air on TV? Boy, that's a tough one. I would say, just off the top of my head, covering tornadoes, the tornado live in Dexter in, I believe, 2015, 2016, can't remember. Did it for a lot of years. 3.5 hours straight on camera without using the little boys' room and barely getting anything to drink because a very damaging and destructive tornado was going through the area and warning people about that. 98 or 99% of the time, being a TV meteorologist is not necessarily all that exciting. You tell people there could be some snow flurries and it'll be sunny tomorrow. But in times like that, you literally can help save somebody's life. That's what we train for. That's what we prepare ourselves for. And when it actually happens, it's kind of a big moment in terms of doing live television because it can be that impactful. Thank you for asking. I have thought about it. Okay. Thank you very much for those comments to you, Amy. I appreciate it. She's thanking me for my positive attitude and disheartened by non-believers. But I just have to say just a little bit more here. I have a lot of discussions with young people. We happen to, as I showed you earlier, we have 2 children who are in that category. And I have to say I am so affected by how many young people are really, really, really concerned about this. I cannot tell you how many young people, I'm talking about people in their 20s mostly, who have said things to me like, I don't think we're going to have kids because I just don't think that the planet's going to be able to really sustain them or that I should bring them into this kind of world. Oh my gosh. I'm not just saying that bugs me because I want grandkids. This is a hugely different issue when you talk to young people versus talk to people that are a little bit older. Many of them are disheartened, and I appreciate their honesty when they share that. I really do. But I think if nothing else, it should get the attention of those of us who, let's be honest, those of us like me who have lived a considerable amount of life, the worst impacts of the changes that we're talking about will happen after I've already moved on. So it's tempting sometimes to say, wow, that's really, really a bummer, but I don't have that much time and energy left anyway. I'd rather do other things. I don't buy that. These young people and the people that haven't been born yet deserve for us to do everything we can. And when I say us, I mean each and every one of us, regardless of our age, to do what we can. We can't all do the same thing, but we can all do something. And when you talk to young people, it tends to get your attention. At least it certainly does mine. And thank you again, Amy, for those comments. What are your opinions on the increasingly likely severe weather? We've probably gotten more rain and thunderstorms than we have in past years. Correct. I will tell you this, Justice, that there is not really clear, convincing evidence in the research between more severe weather and climate change. It makes sense that we would have more, but there is mixed data about whether or not we actually are having more. I will tell you, you see a whole lot more tornado videos than you used to, but that's not necessarily because we're having more tornadoes. It's because everybody's carrying one of these, which is a documenter of severe weather. And it isn't necessarily that we're having more, it's that we're seeing it more than we ever used to. So that's one thing to consider. You might have your own memories and say, well, I don't remember there being as much severe weather in my area, whether I saw it or not. And that's possible. And it also makes sense that greater amounts of moisture in the atmosphere, moisture is one of the main drivers of severe weather, meaning thunderstorms, tornadoes, hail, and that sort of thing. So it makes sense, but we're not necessarily seeing that play out in the data. My personal opinion is, marking opinion here, that we probably are experiencing more, but it's not one of the most dramatic changes that we're seeing as a result of climate change. But we'll see. We'll see how the data plays out, because like all of these things, it's being studied very carefully and continually as we move forward in a climate changed world. Thank you. Okay, comment from Mary Ann that the recent space travel options being offered for money is very concerning, tremendous emissions being emitted. Understood. Understood. Yep. There are a lot of emissions as a result of that, and there are a lot of resources being devoted to that, which some could argue could be better directed toward keeping the planet where we're 7 billion of us are living are going to be for a long time. That's a matter of personal opinion, but your point is a point of fact. There are a lot of emissions that come from that. Yes, and a lot of resources being committed to it. Any other questions? Again, I apologize for the slight delay. I figured out what it was, but it took me a while, slight delay at the beginning. I appreciate you all hanging with me on that. And Joe, it appears there are no other questions. Perhaps everybody's cat is climbing around and they can't ask questions.
Well, I hope they fared better than I did. I have 3 nice little holes in my arm.
Oh my gosh, I'm sorry to hear that. Oh, that's
not
a bummer.
too bad. Just you know how they are.
Indeed, yes, we used to have cats. I certainly do know how they are.
But yep, thank you very much. With that, I will say thank you everyone for joining us. And I hope you all found this as enlightening as I did. Thank you very much, Chris, for the wonderful presentation. If you have any final words, please feel free to share them with the audience now.
I guess in conclusion, Joe, I would just reiterate what I said before, that I'm grateful for your attention and your time. I recognize that this is a topic that is highly polarized in some circles, but what I presented to you this evening was a collection of facts with very, very little opinion mixed in, and I tried to be very clear when it was opinion mixed in. There is very, very little difference within the climate community, within the climate science community, in terms of what's going on, and where there is uncertainty, I tried to delineate that this evening. Having said that, I just once again want to leave you with a request that you do at least one of the 10 things on there, and you can start with talking more about climate. We've got the holidays coming up, and we can start thinking about different things that we can do. We can all make a difference. It is not too late, because it really is simple, serious, and solvable. And I'm very grateful to all of you for giving your time and attention to it. And perhaps we will see each other again talking about this or something else in the future. I very grateful for your time.
Thank you very much, Chris. And again, thank you everyone for joining us. With that, we will go ahead and wish you all a very pleasant evening. And thank you very much. Good night, everyone.